Okay, welcome back. Up next is Carlo Daffara with Disaster Recovery with OpenNebula.
So, good morning. Thank you very much for being here. As you can see from the beautiful and tranquil and relaxing scene behind, I will be talking about what to do when you, let's say, are asked to prepare for a disaster, or what you can do to, let's say, prevent the worst of what a disaster can do to your infrastructure. Let's imagine that you are the system administrator that comes Monday morning and discover that something is not working. The first solution of an engineer is, of course, getting some coffee. The second thing is learning a little bit more about what is a disaster and what to do to prevent it. So, it's very easy to see and to understand when you're facing a disaster. This is a disaster, for example. This is a disaster. This was a disaster. There are these people that still cries a lot when you're facing this kind of thing. To understand what's a disaster, it's very easy. It's that thing that makes you want some coffee. And disaster recovery is a very, very, let's say, vague term, like a cloud or whatever, that basically tries to convey an idea that you cannot prevent a disaster, because disasters are by definition something that cannot be prevented, it can be ameliorated. But the point is that disaster recovery helps you in at least put some of your IT system back in order to provide the services that are considered to be vital. It's not it does not actually mean to recreate the same thing that was before. Usually you create a smaller thing, sometimes you create a slightly different thing. In some cases it's just a web page that say, I'm sorry, we got hacked and we lost all your credit card data, but come back later and we will sell you something else, or something like this. Disaster recovery focuses on IT or technology system supporting critical business functions. We will see later that some of this provides us guidance on how to do things better. Why we talk about disaster recovery? Because the majority of companies that face a disaster never recovers, because they don't have disaster recovery. 80% of businesses affected by a major incident never reopen or close within 18 months. This is a very interesting statistic just from 2 years ago from AXA, which is one of the largest insurance groups. And it's one of the reasons why, if you have a very good disaster recovery in place, you can usually even ask your insurance to lower their prices, because you are less a risk for them, which is a very good, let's say, business incentive to do so. We managed to recover from our disaster with just a few $1 billion lost in revenues. The biggest problem of disaster recovery is that most of disasters are caused by humans. Not in the let's say, natural sense, like they are building where they're not, or they are destroying the earth, or whatever. But the fact that majority of incidents are caused by humans in the sense that they are caused by human error. In 2010, it was estimated that 40% of all data losses were caused by human error, both software and practical human commands given in the wrong moment. Earlier in 2005, it was estimated as something like 80%. This is a slide that I really like. It comes from a few weeks ago. It's the presentation that one of CERN people gave at OpenStack. And it shows what is the example of human error. you get in the circle, in the red circle there, finger trouble led to loss of 246 images. That's something like 20% of their data lost because of a finger trouble, which means that basically, oops, I deleted it and I emptied the trash. They restored 44. Just imagine, this is CERN, so they basically recreated everything from scratch and whatever. But imagine your bank that calls you and say, I'm very sorry, due to a finger trouble, we deleted your bank account. There is a 5% probability we restore it, maybe. Then you have other situations, like, for example, the emergency power off, which is something that is in many countries, it's obligatory to have. It's a global switch that kills off power to allow for firefighters to enter an office and make sure that they can use whatever is necessary in terms of chemical products or sprays and so on, without having to worry about electrical power present inside. It's especially used for power plants and so on. And you get those wonderful example of optimal positioning, like this one. When you open too much, you basically shut off everything. Or the other one, when you have the fire button just on the side of the emergency power off, they had to put a post-it that say, don't touch. You know one thing about post-it is that the glue inside of the post-its exposed to air lasts a few days. So after a few days, you see the post-it goes down. And the next time someone say, oh, there's a fire, let's shut everything down. In fact, 26% of human errors in medium to large data centers were actually caused by people that did the wrong thing. And my best example is the paper delivery person in the last line. This guy was sent with a very big pallet of paper, and they basically, he thought that the red button was used to open the doors, and he opened the doors, the power got shut down, everyone was in the dark, and say, well, now you don't have your computers anymore, you have the paper and the pens to work again. So, if disaster recovery is so important from the point of view of the system administrator that is using, let's say, not unlimited funds and does not have an unlimited amount of time and money to save things, because that will be very easy to do. The first thing that you have to do is define the problem. Not every disaster recovery infrastructure is the same. Actually, they are always different, especially because when you want to recover something, you have to recover it at a specific point of time. So you have two parameters that basically define all the requirements that you will have later on in your, let's say, project. The first one is the recovery time objective. There's a very long description of what is, but basically is, I want my company back in 10 minutes. You usually get a call from someone very important, say, I don't know, someone shot that big red button, not me, but I want my ERP system to be online in now. Now usually is let's say, is a term that can be substituted for 10 seconds, 1 minute, 1 hour, 1 day. There are companies where the server or the computer there is used just to project the night blue lighting, and is basically no more effective than a lamp. So even if it doesn't work for a day, say, oh, I don't have my lamp, but it's not very important. The recovery time objective is 2 or 3 days. There are companies where if the ERP stops, it's a real problem, and they want it back in the minimum amount of time that's compatible with economics, which means a few minutes. There are companies or groups where the recovery time objective is 0. We have as a customer the Civil Protection Agency of my region. They handle all the emergency, and all the signals from a set of, let's say, systems that are used to help in case of earthquake, floods, and so on. If it stops, it's a real problem. That is, someone may die in that 1 hour. So the recovery time objective is the minimum possible. It's never 0, but it may be shorter, as short as possible. The other one is the recovery point objective, which is a widely different thing. It's how much data can you afford to lose at the restart moment. That is when you reach the recovery time objective. It doesn't mean that it's lost forever. It means that it's lost in the period up to the RTO. So, for example, you have constant snapshots and you have the snapshots outside, and basically every night you get a snapshot of your mail server. You lose everything inside of your main building and you are recovering from a snapshot. Then your recovery point objective is 24 hours maximum, because it's the time between one midnight and the other. It's of course probably smaller, because it happens, let's say, at 8 in the morning. You're losing everything from midnight to 8 in the morning. But in general, it's the maximum tolerable period for which data might be lost. Because sometimes you recover from your server that is navigating on the water, or from the hard disk that is hidden by acid, like one of my friends had it happened, or something like that. You may recover something, but the point is that when you ended your recovery, how much data you have lost. You are willing to lose, or you're able to lose. One of the reasons why many companies or many organizations are not using disaster recovery is that the majority are tuned for very large groups and tend to be oriented toward pay by the terabyte protected. So, a small company nowadays has tens, in the 10 of terabyte of data inside of their companies. You're talking about $100,000 of software, hardware, services, consulting, whatever. So you're talking a budget that is usually unavailable for the majority of them. But it's something that can be done, and it can be done quite easily thanks to some of the properties of OpenNebula we will talk later. There are a few simple rules to start thinking about making a disaster recovery infrastructure, which is not a plan. A plan is one of those things that's usually very large companies do have a disaster recovery plan. It's something that they paid a lot of money for, specialized consultants. It's a very big black book. They say, open this in case of disaster. Something like 500 pages, and say, if there's a fire, there's one lucky guy, that's the DR manager, that has to take it, open it, and while everyone flee the building, he say, now open this one and say, let's call the manager. Is there a fire in the building? Yes. Then try to see if there's someone else there, and so on. The DR manager usually is the first that has, let's say, problem in being kept alive in this situation. The first rule is never put everything in a single basket. It may be, let's say, common sense, but it seems to be the first rule that is never applied. This is one of my best examples. There's a company that managed source code in helping in things like auditing and so on. They were exceptional. The website said, we are totally backed up. We have 100% reliability, 99.99999, and lots of other nines and so on. And they were lost in one day. Why? Because they had everything on Amazon. Someone stole their credential and basically erased everything. Because their backups, their snapshot, their everything, were in Amazon under the same name. So, when you delete everything, yes, the company was no more. And someone said, well, that's a nice way to put it. This happens to me. I received a call in the middle of the night. A customer decided to buy a disaster recovery solution from a local data center. It was sent, they sent him a wonderful brochure with lots of images of safes and heavens and things like that. And they basically bought everything from them. Disaster recovery, snapshot, backups, and so on. And they lost everything because the data center had everything in a very, very large and extremely costly box. And someone decided to upgrade the storage area network firmware for this box without reading in the instruction, in the release notes for the update, that the update was destructive. And so they wiped out 196 terabytes of user data, including every backups, every snapshot, everything that was held inside of the storage area network. And the nice thing is that the email that was sent to the customer explaining this little problem, in the bottom has something like, we hope to help you in realize your technical whatever, and so we are proud, ISO certified, DS certified, A, B, G, D. They had lots of certification. And in no way, in none of this certification, it was written that you cannot put every snapshot and backup in a single place. You imagine the situation, it's 10 p.m. in the evening, and you have the customer that probably because of the shock say, I lost everything. Can you do something? The first thing is never put everything inside in a single box. The second thing is never trust a single software and insulate one with the other. In electronics, there's a component that's a wonderful idea. It's called a photocoupler. It's actually a very small chip. Inside there's a light emitting diode on one side and the receiver on the other, and the two pieces don't touch inside. There's no silicon there. This means that whatever current is going on in the first in the first two contacts, never reach the other. And this is an important principle in disaster recovery as well, because apart from human error, there's another very huge cause of disaster, which is software. Software upgrades, software changes, configurations. All of them can destroy both sides. And so it's important, if you want to have something that survives you, to have some way to insulate one with the other. And to have more than one way to prevent disaster. This is a wonderful example of ingenious engineering. This is a nuclear reactor. It's more or less like your computer. There is one part, which is this one, the freeze plugs. It's something that is actually quite brilliant. There's a block of ice that's constantly cooled. If the ice melts, because there is no power at all available, not even emergency power, the ice block melts and provides a discharge for the molten liquid on top. So basically, it tries to have something that works even if there is nothing else that works. Disaster recovery needs to be done in a way similar to this. There must be, let's say, an emergency escape, let's put it this way, that can at least freeze everything before it may further damage. We will see later what do we mean with it. Rule 2. You don't have to apply the same recovery time objective and recovery point objective for every VM. It's, first of all, useless. It's totally a waste of resources, and it prevents usually you from making a real disaster recovery. The point is that, let's say that you are this poor customer. This is a schema of the set of IT services of public administrations. You have hundreds of components. Not all of them are critical, and not all of them do have the same recovery point objective. So trying to do everything at once is trying to say that all of these containers are the same and I need to bring them exactly in the same time. That's not true. There may be one that needs to be absolutely saved because there's everything important in there, and there are other. I don't care if one of these is lost because maybe there's an ISO of something. It was an experiment. I don't know. But the real point is that you need to make an inventory of what you have, and that's a very important thing because you will discover that only 10% of your VMs are really critical, usually, and are those that where the recovery time objective is shorter. The majority of them can be recreated from other sources. In fact, NASA does have a group of software classes from A to F, I think. And there is the class A, where there are humans, and a failure may means that the human may die. Those need to be preserved, and the recovery time objective for them is 0. Because you cannot afford to lose anything in that case. But there are other situations, like, for example, this one. This is the full software classes. General purpose desktop software. I lost my Microsoft Office. Oh, I feel better, actually. So it's important to recognize that you are not saving everything inside of the company. You are saving just the critical part of it. Rule 3, design a reliable oracle. This is the other important thing in your disaster recovery. When do you call a disaster? It's not that easy to see that, for example, nothing here works. Maybe something works and something not. If you remember the image where the submerged servers, maybe half of the servers that are on top were already working. Maybe some of the servers down there that were learning to swim are able to do something as well. But the point is that you have to design an oracle, which is not this one, because you will pay a lot of money just to print the name, but this one. The oracle is a combination of, usually, software, services, and a human that decides when it's necessary to initiate a disaster recovery procedure. This is one of the most difficult part. If your company is simple, it's simple. I have 10 VMs, 2 of them are critical. If I am unable to reach in any way, and this means more than one way to reach them, these machines, and I know that it's too late for start something else, then we start a disaster recovery. Usually there's an initial part. The oracle is an application that warns you by SMS and say, well, it seems that there is some problem in your premises, and sends you a photo of a fire or something like that. And you say, okay, initiate a disaster recovery. But it's difficult. This is, if you know systems theory, observing the state of a system and estimating its states is as complex as the system you are estimating. So it's how the others do it. This is the majority of companies selling disaster recovery services are doing it on external clouds. And this means that they do have lots of levels because they don't want you to pay for having the VMs running all time. Let's imagine that you have 100 VMs on one side. You will have to have 100 VMs on Amazon side as well, including all their storage and whatever, running in real time. That's why you have Pilot Lite fully working, low capacity and multi-site and so on, which is a huge problem because basically you start to have to count how much you're paying Amazon for disaster recovery and the company that does the disaster recovery and so on. It's much easier to do those kind of things with OpenNebula, of course, or they not would have invited me here. With just one warning, this works quite well for us and for some of our customers. It needs to be adapted to your customers or your needs. So I will try to give you a few words of how to, let's say, adapt it to more than one situation later. We use a combination of two things. The first one is OpenNebula because it's beautiful. And the second one is a distributed file system that's called LizardFS, which is a fork of MooseFS. They are basically the same thing. It's a distributed file system that is based on a few peculiar capacity. The first one is that snapshots are basically instantaneous, that they don't take space and they are always thin provisioned, and it's based on chunks. Every file is divided into chunks, and these chunks can be sent basically everywhere. So, this part, how LizardFS and MooseFS creates a snapshot, is basically by having a tree with the full metadata on always in RAM. And whenever you create a snapshot, you are basically just replicating that metadata. So it's instantaneous and it doesn't take space. If you modify the source or the snapshot, it creates a new chunk and simply rearrange the metadata to point to the new one. Chunks are counted and numbered. So let's say that, for example, you don't need file 1 anymore. The metadata will be destroyed. And in this case, for example, the chunk in the end will be deleted because it's not referenced anymore by anyone. It's very efficient. Snapshots are read-write and basically are exactly like files. It's impossible to distinguish a file from a snapshot, which is a property that we use for doing the duplication, which is something that helps you when you have many snapshots. The other interesting feature of LizardFS is the fact that write are performed through a set of chunk servers that in our case we place exactly on top of the same machine where we run the virtualization with the KVM and OpenNebula. Chunks do have one important feature, which is a tag that's called a goal. Usually the goal is very simple. For example, goal 3 means make sure that there are at least 3 copies of this chunk. When you write the first one, immediately the other chunk server propagates the fact and say, I need to have other 2 copies, so they ask for other chunk server to get a copy and so on, up they reach the original goal. If one node dies, each chunk server recognizes that there are chunks that are under goal, because those chunks are not available anymore, and they try to find the space and place where to put another copy so they reach the goal again. Originally, the goal was simple, a number, which is, let's say, good enough. But then they extended it with tiering and tags. So, for example, you can say, I want to have 3 copies, 1 copy on SSD, where it will be used by the virtual machine, 1 copy here on this rotational disk, and 1 copy remote site. So you can have geographical streaming. And you can have even more complex situations. You can even have, let's say, things, it's a little bit extreme for me, but for example, I want a copy on a Western Digital disk, I want a copy on a Toshiba one because I think that this one may fail faster or whatever. The important idea is that you can have a concept of geographic affinity. So what we do, especially for public administration, that for example in Italy public administration are required by law to have a form of IT disaster recovery. The majority of disasters are local, first of all, because as we said, most disasters are user-driven and the user is usually a single stupid in a single room, so we can contain it in some way. Other disasters tend to be local as well, especially UPS problem, electrical problem, fires. They tend to be concentrated in a region. So, for example, you have a production plant. You have 4 or 5 OpenNebula nodes. Everything from OpenNebula is stored inside of LizardFS, including the database, including the virtual machine, everything. So it gets replicated for free. Then you get 2 nodes on the other side of the building. And you basically stream everything there as well. Storage cost is very low. A 2 terabyte disk is $80, $90. So you can stuff lots of disks inside of a node just to have all the copies. Those copies are real time. So, well, let's say that there is a 1 second delay, but you can basically assume that you are at a recovery point objective of 1 second. Because every change that is propagated to remote node as well. Then you have, let's say, at least an initial capability of recovering. In most situations, it suffices. In one of the municipalities where we installed this kind of thing, most municipalities are connected by fiber optic cables in my country, and basically it's an internal network between them. So they have 3 nodes on one building, and they have 2 nodes in a school building where they have a small closet, and they basically are streaming constantly. In this case, what happens is if the, let's say, municipality data center shuts down, we have a very simple failover mechanism, and we start OpenNebula and everything else on the 2 remote nodes in the school. It starts lower, it starts only part of the services, but basically they perceive only the stop in the time where the VM are reinstantiated on the other side. Then you have the remote side. And for this we use one thing that I really love of OpenNebula, which are the data stores. We have created a few custom data stores. The easiest one are this one, Goal 1, Goal 2, Goal 3, Goal 4. Basically, each data store is a directory, and we ask LizardFS if something falls into the directory that's called Goal 3, replicate it 3 times. If it falls in Goal 4, replicate 4 times. If it's something that I downloaded for the internet or in an ISO of an operating system that I can re-download and so on, and I don't want to lose space for storing it, I can use Goal 1. Then I have 4 spatial data stores. They are marked for disaster recovery. That's DR. DR 2L 2R means 2 local copies here and 2 remote one. So in the municipality and school example, I want 2 copies at least in 2 nodes here and 2 copies in 2 nodes there. 2L 1R means, well, it's critical but not that much. It's 1 copy remote suffice and 2 copies here. And then you have the snapshots one. Let's say that you want to make sure that some of these images are stored not in the building next to yours, because something may happen to both buildings. You want to have something outside as well. In this case, it's impossible, usually, to have a real-time streaming of chunks. If you have 100 virtual machines, it will be tens of gigabits just to bring out all the changes. It will be useless, because as I mentioned, we actually don't care to have a recovery time objective of 0 for a machine that sits there and basically is a web server. It's useless. For those, we take advantage of another factor. We take advantage of the fact that a snapshot, unless we make changes, basically does not add any new chunk. So it's a form of deduplication. It's very easy deduplication. We make snapshot of snapshot, and we replicate everything on the other side through sync queues. It works like this. Local means here where the disaster may strike. Remote is some data center somewhere. We usually take offer of those dedicated server offers that are something like 100 euros per month or whatever. So you have your dedicated node and everything inside. On the local side, where the change happen, where there is a virtual machine that is changing those chunks, that is changing those sectors, we take a snapshot with the time that is indicated inside of the data store. So we have 1 hour snapshot, 12 hour snapshot, 24 hour snapshot, weekly snapshots, because things may not change that fast. When you, on the other side, apart from the first synchronization where everything is new, because on the remote side there was never any synchronization, so it's empty. We do the initial synchronization, then we take snapshots of those snapshots. At this point you should say, okay, this guy is an idiot, because you are doing a snapshot of something that has not changed. Because here we don't have virtual machine, there's no one that is changing those things. Consider that this one and this one, for the Photocoupler pattern, are totally distinct installation. This is a LizardFS installation. This is a separate LizardFS installation. They talk only through rsync. The point is, if I do an in-place rsync of this, let's say, directory structure, I'm actually creating a new chunk here, so I'm taking up space only if the difference between the previous day snapshot and this one does match a change in that side, which means that we are doing a very, very simple form of the duplication in the temporal sense. It works very well. In fact, remember that you must do an in-place rsync, because as we discovered the first time that we tried it, rsync creates a new file and then moves over the file. So it creates, every time it was creating new chunks, and we weren't able to understand why. We got more coffee, and after more coffee we understand that the secret is having it exactly in the same place. And you get a very nice, on a 1.8 terabyte set of around 12 virtual machines, reasonably used inside of a company, we got a 25 times speed up. So it's fairly good, and it means that it's capable of doing a remote snapshot that is coherent, because LizardFS snapshots are always coherent, because they preserve temporality. And we just have to add as a little, let's say, help for, especially for the Windows, on the Windows side, the support for VSS inside of this snapshotting process. Before taking a snapshot, you send to the guest that is inside of the Windows side the VSS message freeze, so everything is that is in cache is saved on the disk, and then thaw when you have finished to do the snapshot. The snapshot is instantaneous. It really takes something like 1 millisecond. So it's basically not even perceptible for the majority of customers. This means that even on a very, let's say, normal internet connectivity, you are able to do remotization, full remotization of the entire structure of your company outside, which means that if something happens, you have a full open nebula ready to start on the other side. The other aspect is estimating data consumption. We are not interested in reading. We are all interested in writing, because what we are interested in is what changes the state of the data store, because that's the only thing that we need to replicate on the other side. In most situations, it's possible to see that actual read, actual write to the data store average for in a day tend to be not that, let's say, incredible. If you need to have specific information, and that's one thing that we would love to have added in the next version of OpenNebula, is to see how much write operation a VM has done, which is very simple to do. You just enter into VRSec and you send DOM BLK stat, and you get the basically how many writes have been done on that disk. It's used just as an estimation. You don't need to have a precise number, just having an idea. How many megabits per second do I need to perform a snapshot every hour of this VM that writes this amount of data there? So you basically have an estimate, you try it, and you try to take a good, let's say, percentage of advantage just to make sure that it works every time. This way, it's possible to design a DR scheme that works on each DSL line, on even on a DSL line if you're not working too much on those hard disks. There are a few things that needs to be done on Windows. Go figure. For example, you have to disable the automatic defragmentation. Defragmentation changes every sector on the disk. So the poor LizardFS basically thinks that you're formatting everything and has to send lots and lots of write requests on the other side. It's very easy to do. The other easy thing to do would be not to use Windows, but that's... We have a variation of the pilot light method. On the remote side, we have two nodes. So if one fails, the other is ready to start work. It's a running OpenNebula with LizardFS and so on, which is essential because you will not get snapshots or differential or whatever. And two VMs, the Oracle and the tester. The Oracle is actually a very simple network monitoring server. You can use whatever you like and basically sends you a message that say something is happening, maybe it's a disaster. The tester is a very simple machine that tries to verify that what you have on your side is actionable, which is the other side of disaster recovery. You copy everything, but you must be sure that what you have copied actually makes sense. Which reminds me, I got a call one evening from a company that lost basically everything because they thought that backups were not for important people. And they discovered that they had a network tape unit and say, oh, I'm sure that there's a tape inside, so maybe some backup has been done. But actually, the poor guys had the tape cleaning unit inside for 7 years, I think. So they had the cleanest unit in the world, but not a single data. So you have to understand that what has been copied needs to be able to be restored. The tester is very simple. Takes a snapshot of your current snapshot, since it's no more space for you. Creates a separate network and just starts the VM inside and performs simple tests like to check if there's RDP on the Windows machine, if HTTP is working, and so on. Tests that can be used even without external network connectivity, because this network is not going anywhere. It performs the test and say, okay, this backup is working. Then destroys everything. You don't need it. You just need the message that tells you that if it's there, it works. You need to install only the critical VMs. If you have lots of VMs and you basically need to move everything because something really dramatic happened and you flooded everything and you don't have a server anymore and so on, you go to a company that sells you servers, the dedicated servers. Basically, in 30 minutes, they give you a server for a week for $49. You buy 10 of them, you auto-install the base operating system, that is LizardFS, and nothing much, and no much else, because OpenNebula is on the other two nodes, and you basically start everything there. This is important. You never start everything at once, because usually you don't know how many workloads were in execution. Sometimes some of the workloads were not executing. You have VMs, but you don't need to start all of them. Usually this is a manual process. That is, you selected, for example, the ERP is a useful thing, the other things may not that important. There are lots of small other things with some, let's say, effort. You can create something like this. This is a portable data center. It's very useful. You can bring it like a trolley around. It's shock-proof. It does have a small UPS in the bottom. It runs OpenNebula and does even have a Wi-Fi router inside. So you can basically say that if you don't want to have a remote site, you can have your along with you. Sometimes there are little things that may help a lot. Some of my customers are industrial plants and facilities where you have dust that flies around, you have electric current basically everywhere, you have problems of static discharge and so on. There's one small suggestion: you invest a little bit more in a rack that is designed for environment you are using. Using a traditional rack for networking device, for example, when you are near an industrial cutting machine, that each time that it trunks something generates a spike that resets everything, which is something that I happen to see personally. You see, everything stops down. And then everything starts and restarts things and say, we don't understand why we have to change servers every week.
Carlo?
Yep.
Can you wrap it up?
Yes, I will wrap up. So, you can invest a little bit more in a better enclosure, and you substantially increase the probability of your servers surviving. If you're living in a war zone, there are even server farms that are designed to live, they are boom-proof, completely boom-proof, are very nice. And just to wrap up the last few slides, since I would love to leave you with something more to think about, never do disaster recovery in a total automated way. Sometimes you have a problem, you are firefighting here, for example, you have storage problem, networking problem, whatever, and the disaster recovery system decides that you want to move your VMs on fire on somewhere else. So you're firefighting here, you're keeping your VM here. Don't leave me, please. The second thing, the disaster recovery people is someone that is able to use OpenNebula basically to restart a machine. So it's not that difficult. Have two of them, give them a second phone with a rechargeable. So it always works, because sometimes their phones doesn't work when there is a disaster. One operator may work, on the other not. And make sure they don't go on vacation together. And actually it happened to me as well. Internally, you can use a gateway machine to provide a consistent IP scheme, so you don't have even to reconfigure your VMs where you move them away, because remember that in this scheme, you get a remote copy of everything that is here on OpenNebula. So you cannot use things like the name of the host or whatever, because everything is the same from one side to the other. If you can optimize writes, because writes are the things that change your data store, so the things that needs to be replicated abroad. One thing that we found that works wonder is have a virtual machine that manages logs. Every application manages logs in a different way. If you can compress them in a single one, you can stream these writes in a single place, possibly compressed. So it's much more efficient. This is a personal preference. I like consistency, so I really hate when you have, for example, one VM here and one there, and you stream changes like in distributed MySQL or whatever, because you get lots of problems when you have a copy streamed in another side. A perfect example is SQL Server, that basically when you replicate the same disk and the same everything on another side, it stays there are two machines with the same UUID, something critical has happened, call Microsoft immediately and pay someone. And the other one is try to reduce write amplification. One of the worst problems of replication is write amplification for databases, especially MySQL, which is one of the worst in this sense. When you write a few kilobytes in MySQL, you end up writing several megabytes on disk. And you have to replicate all of them, because we must maintain temporal consistency. There are different data store that tends to be even faster. For example, there's one thing that's called the fractal tree, which is used in a storage engine called ToQDB, that basically writes 1/10 the number of writes that MySQL performs for the same amount of data. Just a suggestion, because it may help. Sometimes you want to have consistency, strict consistency for a MySQL database that is used a lot, and you want this kind of streaming things. Sometimes changing just a little bit of the interior allows you to perform it even on network connectivity that is limited. Thank you very much.
Thank you, Carlo. Any questions?
Sorry, can you repeat? The question was if LizardFS is supporting OpenNebula. Actually, it's much easier than that. The LizardFS is mounted on every node and is seen as a shared data store. So it's like it's quite similar to how NFS, for example, is managed. So we changed a little bit. Actually, we used a modified transfer manager that designed for a previous version of MooseFS. And the only thing that we changed is basically that when you copy something in OpenNebula, instantiate or whatever, you substitute CP with the equivalent LizardFS command for doing snapshots. Everything is done through snapshot, and so this way it's basically instantaneous. So there's no need to, let's say, it's a very small change just to support everything inside. As I said, everything runs inside of LizardFS. On a DB, all the data stores, the VMs are executed there, and so on. So there's no need of a spatial adapter like maybe for SAP, for example, or Sheepdog. Yeah. Yeah, the question was if it's, let's say, it's possible to integrate a backup strategy for this. Is it correct?
If you have a backup, because this is not a backup, this is a replication.
Oh, yeah.
It's a very good replication.
Yeah.
But still you need to have a backup.
Yeah. Yes, actually, we have a strategy specifically for this. We have a VM inside, that performs the backups on the images that are inside of the data store. We handle backup in a very simple way. Basically, we make a copy in an external cold storage, and we delete them as usual. I must confess that we use a very simple, I think it's Amanda as a VM. Any backup appliance can be used for doing this, because basically you make a snapshot to make sure that it doesn't change when, yeah, and you back whatever you want to back up. The question is how we handle, how LizardFS actually handles the consistency issue of writes and replication. It is done in a very clever way. It's done through a versioning process in chunks. There are multiple metadata layers, and every modification to a chunk introduces a new metadata with a specific temporal interval. So every time, for example, the first chunk that is written, that chunk is written and it does have a generation and a precise, let's say, CRC attached to it and so on. And they immediately start streaming. Let's say that you lose this node, so you lose the chunk, and you even don't have the ability to stream it to someone else because it died with everything else. At that point, when you restart it, because this means that you have lost basically everything, when you restart, it will check for consistency. It will return the metadata to the last consistent state, including the chunk that you missed, removed as a transaction. So you are returned to the instant just before that chunk got committed. Of course, that's a worst case scenario, but the idea is that consistency is kept basically every time. I can testify that we have situation where the customer decided to shut down everything many times per day, and basically it always recovers to a correct point in time. This means that you may lose a transaction that you just committed, but that's basically unavoidable, because it means that something strikes exactly in that second where a replication was started.
Okay, thank you, Carlo. Let's head on to the lightning talks. You can catch up with Carlo in the break later, I guess. Thanks.